So this video looks at the hard questions for the calculus of inverse trig. So we've got two types that we're going to look at. This is question 3 on page 24. And this requires us to use completing the square. And then we're going to add a question 4 that looks at the method of splitting the fractions to allow us to integrate. So, question 3. I'm unable to factorise the bottom and use partial fractions. So the method I'm going to use is completing the square so that I generate 2 squared terms on the bottom, and that will then allow me to compare to the formula book and use the appropriate inverse trig integration. So let's consider the x squared plus 6x plus 25. Complete the square on this, so we have x plus 3 all squared minus 9 plus 25. So that gives us x plus 3 all squared minus, that's 16, but I'm going to write it as 4 squared, so we have 2 squared terms. Now let's put that back into the integration in a format. I'll call that I, so I equals 9 divided by, we're going to have 4 squared, sorry that's a plus there, isn't it, and x plus 3 squared, so that I have the x term here and I can compare easy to the formula book. When I compare to the formula book, I can see that it's going to integrate to arctan. So I have a 9 at the front, I have arctan 3, and we're going to divide that by the 4. And we're also going to divide the overall function by 4 and then add on the constant of integration. So that's integrating using the method of completing the square to allow us to turn the fraction into a format that we can integrate with our inverse trig functions. Okay, now let's have a look at this example, which is taken straight from the textbook. And I've included it so that we can look at how we deal with the integration of this type of fraction. So we are going to split it into 2 fractions, x over the square root of 1 minus 4x squared. And then a second one, I've split them completely so that I can divide up my working. We will have 4 over square root of 1 minus 4x squared. Now, let's consider them separately for a moment. If I look at this one, if I differentiate the bottom, I'm going to generate an x. So it looks like I'm looking at integration by inspection or possibly substitution if I'm not sure. So we'll use substitution on this occasion, but my method is either inspection, which would be my reverse chain rule, or I could use substitution. So if we're going to use substitution, we're going to let u equal the 1 minus 4x squared. Pre-working, du by dx is going to give me minus 8x. So du will be minus 8x. Divided by minus 8x equals dx. So substituting in, I'm going to replace dx with du over minus 8x. That means that the x's will cancel. So I've got 1 there. I've got a minus 8 on the bottom of a fraction. So I'm going to take that out front. So we've got minus an 8th. And on the bottom of the fraction, I've got the square root of u, and by using my pre-working, I've got du. So I can now integrate u to the minus the half, which gives me minus 1 over 8. Increase my power by 1, divide by my new power, I'll get a 2. Plus c, and then if I sub back for u, I will get 2 times 1 minus 4x squared to the half, which gives us minus a quarter square root of 1 minus 4x squared. So that's that part of the integration with our final result there. Now let's consider the second half of the integration. This is in a format that we should be becoming familiar with. I've got a square root and I've got potentially 2x squared terms on the bottom. So I need to write it in a format that matches the results I'm going to use from the textbook, and that means that I have to factorise because I don't want a 4 in front of the x squared. So let's take the 4 from the top out the front. Let's have a 1 over, and we've got the square root, and I'm going to take a 4 out, so that means my bracket becomes a quarter minus x squared. Simplifying that, we've got 4 divided by root 4. We've got 1 over a half squared minus x squared, and those are square rooted. It's now in the format where I can compare to the formula book. I've identified the x and the a. So that gives us the result. This simplifies to 2. And it's an arc sine, and we have x divided by the half plus c, so that simplifies to 2 arc sine of 2x plus c. Now, I've now got 2 results which need to be put back together to give my final answer. So my integral is going to be minus 1 quarter square root of 1 minus 4x squared plus 2 arc sine 2x plus the constant of integration. I wrote it there. I could have written it here as I was carrying on down the page, but I only actually need the 1, a combined constant of integration there. So that's my overall result for an integration where I'm required to split the fraction into 2 parts, and invariably the 2 parts have a different method of integration.